All right, guys, welcome back to our chemistry flipped classroom, where today we're talking about single replacement reactions. So when we talk about a single replacement reaction, you remember from our discussion of types of reactions, we're talking about a reaction where we have an element by itself and a compound. And then in certain circumstances, that element will replace another element in the compound, leaving, again, an element and a compound, but it's a new element and a new compound. So what we're talking about today is how we predict what those products are and how we predict whether or not that reaction will happen, because the reaction doesn't always happen. It really depends on the activity or the reactivity of the element itself. So we're going to start by talking about single replacement reactions where metal is the element by itself. And so whenever we look at a single replacement reaction, we want to remember that the element that's by itself will always replace the element that it is similar to. So here we have aluminum, and aluminum is a metal. And so in our compound, if this reaction will happen, aluminum would replace the metal, in this case, zinc. So now the tool that we use to decide whether or not a reaction will happen is called the activity series. And you have a copy of the activity series, or you can look these up. And so the activity series tells us whether the metal that's by itself, or the element that's by itself, is more reactive or active than the element that's in the compound. So if it's more reactive, then it'll replace the metal in the compound. If it's less reactive, it won't replace the metal in the compound and will have no reaction. So we're going to take a look, and we're going to remember that we're looking for aluminum, and here's aluminum, and we're looking for zinc. Now, because aluminum is higher on this list than zinc is, that tells us that aluminum is more reactive than zinc. Most reactive at the top, least reactive at the bottom. If the element that's by itself is higher than the element in the compound, then we will have a reaction. So this list tells us that aluminum will replace zinc. So let's go back to our equation here. So aluminum is going to come in and replace zinc. So our products are going to be the aluminum, but now aluminum is with the chlorine because it's bumped zinc out. So aluminum has come in and bumped zinc out. And the zinc is going to be all by itself. But now we need to do a few checks. So aluminum, we know, is a +3 ion. Now that it's in a compound, it's the +3 ion, not the uncharged aluminum that we had before, but a +3 ion. We know that chlorine is a -3, or sorry, a -1. So I need 3 chlorines to go with my aluminum. So I'm going to write aluminum chloride. I'm going to put a subscript of 3 on the chlorine. Now, our solubility rules tell us that aluminum chloride is soluble. So I'm going to put an AQ next to this. And now my solid zinc is going to be a solid. So my last step is just going to be to balance my equation. I have 3 chlorines on the product side and 2 on the reactant side. So I'm going to put a 3 in front of zinc chloride. I'm going to put a 2 in front of aluminum chloride. That gives me 6 chlorines on the product side and 6 chlorines on the reactant side. But it also means that I need to put a 3 in front of zinc and a 2 in front of aluminum. And now my equation is balanced. So let's take a look at another example. We have aluminum and we have calcium chloride. So once more, we have aluminum is a metal. So in this compound, if it's going to replace anything, it will replace calcium. So we're going to go back to that activity series. And here's aluminum right here. We've already circled it, but calcium is up here. So calcium is more reactive than aluminum, which means aluminum is not going to be able to come in and pull that chloride away from the calcium. And so because calcium is higher than aluminum, we're going to come back to this reaction and we're going to write no reaction. So pretty simple and straightforward. Don't have to write any products, don't have to balance anything, just have to pay attention to that activity series. So we've looked at examples of metals replacing metals or metals not replacing metals. Let's take a look at some nonmetals. So now we have bromine and we have potassium chloride. So here we have bromine, and bromine is a nonmetal. So if bromine is going to replace anything in this compound, it's not going to replace the potassium because that's a metal. It's going to replace the chlorine because that's the nonmetal. So bromine would come in here and replace chlorine. But now we're going to look at our activity series again. And you might have noticed earlier that we were looking at the activity series of metals. Now we want to look at the activity series of nonmetals. And so we were looking at bromine, which is right here, and chlorine, which is right here. And we can see that chlorine is higher on the list than bromine is. So bromine is not going to be able to come in and push the chlorine out because bromine is less reactive than chlorine. So again, just like we did with the second reaction last time, we're going to write no reaction. So let's take a look at one more example. Now we have bromine and potassium iodide. So again, bromine is a nonmetal. If it's going to replace anything, it's going to replace iodide. So we're going to take a look at our activity series of nonmetals. Here's bromine, and here's iodine. Bromine is higher than iodine, so bromine is going to replace iodine. So we're going to write our compound. We're going to write our potassium, and we're going to put it with bromine. And we're going to stop and check charges to see if we need any additional coefficients. Potassium is a +1, bromine is a -1, so I don't need any coefficients. Any subscripts. So even though that bromine has a 2 over there, it doesn't need it over here because this is a +1 and a -1. And then our iodine is going to be all by itself. But remember, iodine is one of our diatomic elements. When it's by itself, it's never truly by itself. It's with one of its friends. So we're going to put a little subscript 2 to show that that's 2 iodides. Now the elemental state of iodine is a solid. We were in an aqueous solution. So our potassium bromide, that's group 1. So we know that that's going to stay in solution. So that's AQ. And now we need to balance our reaction. So I have 2 bromine here. So I'm going to put a 2 in front of potassium bromide. When I put the 2 in front of potassium bromide, that means that I have 2 potassium. So I'm going to come back and put a 2 in front of potassium iodide. And that gives me 2 iodines to match my 2 iodines on the product side. And we're all balanced. The biggest trick to this is recognizing what's going to replace what and paying attention to this activity series. On the worksheet that you guys are working on, you have, let's see if we can zoom in just a little bit. You have already, I've done number 1 for you. I've said that lithium is higher on the activity series than hydrogen. So lithium is going to come in here and kick hydrogen out. So we'll have lithium oxide and hydrogen gas. For number 2, because bromine is lower on the activity series than chlorine, we'll have no reaction. And for number 3, we have gold trying to react with sodium bromide, but gold is lower on the activity series than sodium, so there's going to be no reaction. So I'll do one more for you because this is one that I did not talk about an example of. So we have magnesium and we have water. When we have a metal, it will either replace a metal or it will replace hydrogen if it's higher on the activity series. So let's take a look at our activity series, and we're going to find magnesium. Here's magnesium right here on our activity series. And we're going to find hydrogen. So hydrogen is right here on the activity series. So magnesium is higher than hydrogen. So magnesium is going to push hydrogen out of the way. And we'll have magnesium oxide. Stop and check. Magnesium's a +2, oxygen's a -2. So I don't need any subscripts because my compound's already neutral. I'll have magnesium oxide, and then I'll have the hydrogen that we pushed out of the way. Remember, hydrogen's one of our diatomic elements, so we're going to give it a little subscript 2. And we know that hydrogen is a gas. And from our solubility rules, we know that magnesium oxide is insoluble, so this is going to be a solid. I have 1 magnesium and 1 magnesium, 1 oxygen and 1 oxygen, 2 hydrogen and 2 hydrogen. So my equation is already balanced. And you're just going to continue with that process all the way through. As always, if you have questions, let me know. Look forward to seeing you in class.